Hi, everyone. Welcome back to my channel. And today we're going to do some math problems. Surprise. So let's get into it. We're still in 2.11. And again, 2.11, what we're trying to do is kind of look at the differences between exponential and linear. So again, when you're learning something and you really have learned it, you're now able to go back and forth between things that you know and understand, if that makes sense. So for example, if you ask me, hey, Ms. Johnson, can you explain to me the theory of relativity? I can't. And they're like, oh, Ms. Johnson, can you discuss the differences, right? Can you explain the differences between the theory of relativity and whatever? And I'd say no, because I don't really understand it. But now as you understand exponential more and linear more, right? Now you're able to understand the differences between them. And then you're able to say them. So the last time we were together, we read this problem and we wrote an equation for it. We wrote the slope-intercept form of it. And we wrote, that's all we did. And we explained that it was linear and it was discrete. So again, this is going to be one of those kind of like sections that puts everything that we've learned all together in a nice, neat kind of like box. So let's go with number 2. It says, write the equation of the line with a slope of -1 through the point of -2, 5. Name the form of the equation that you wrote and why you chose to use that form. And then we're going to answer all of these questions. Okay, sounds good. Okay, so number 1. So what did they give us? What did they give us here? Yeah, they gave me a point. Very good. What else? Yeah, and they gave me the slope. So what equation should I use? Yes. Why should you use the point slope formula or the slope point formula that you guys all call it, right? Why should you use that one? Because those are the ingredients you gave me, right? Could I plug it in and find and use the slope intercept form? Sure. Can I plug it in and use, use the recursive formula? Sure. Can you plug it in, manipulate it, and make it into the standard form? Sure. But really, if you're really going for this, they just want an equation of the line that has a slope of this and a point of this. So I'm going to pause the video really quick. I want you to write out the equation. Try writing the point slope form or the slope point form in your own without like peeking up top here, right? Without looking at your notes. Just see if you can write it on your own. If you did it great, if you did it right, great. If not, right? If not, don't worry about it. Just fix it. Yeah, we'll go back and fix domain in just a second. I saw that too. So for this one right here, I want you to write me an equation of a line and then start thinking about, do you think this function is linear, exponential? Neither. What about continuous, discrete? Neither. And start thinking about the domain. So I'm going to give you a couple seconds to also answer the rest of those equations, those questions. All right, so I'm going to write my equation from memory. And of course, I know my equation because I've been, I'm the teacher. So it's y minus, oops, just kidding. That's the other form. Y equals m parentheses x minus x1 parentheses plus y1. Thank you for being patient and enduring. Like my voice, it's just, I sound funny. All right, here we go. So where does all this stuff go? Where does the slope go? Where does he go? Very good. He goes in the M spot. Good. And then this guy, the -2, where does he go again? Yeah, he goes in the X1 spot and 5 goes in the Y1 spot. So Miss Johnson likes to go Y equals, and then she leaves a little space for everybody. Like it's almost like their spot, if that makes sense. And then I plug everybody in. So -1, and then this is -2, and then this is 5. So there's my equation. I just like to clean them up just a little bit because minus and negative, I can clean up to be x plus 2. Let's just x plus 2 and then plus 5. I will put a -1 there. You can put a -1. You could just put a negative. It doesn't really matter because they mean the same thing. So number one, did I write the equation of the form? Check. It says name the form of the equation you wrote and why you chose it. Can someone put that? Can someone put that? No, you got it right. Oh, did you get it wrong? I'm mad. Oh, I see what you did. Yeah. At least you figured it out. I'm glad you made that mistake, right? Yeah, I'm glad you guys make mistakes. I know that sounds really wrong. Man, Miss Johnson, she's excited when I make mistakes. Yeah, I'm excited when you make mistakes and figure out what you do wrong so that you don't get it wrong during the test, right? Because you reflecting back on why you did something wrong lives outside of math class, not just inside. Yeah, you make mistakes to learn. Okay, if you make mistakes and you never learn from them, guess what? You're probably going to make that mistake again. Okay, so what is the name of this equation again? What form is this called again? Yes, it's called slope point, or to the rest of the world, point slope. Good. I actually like that you guys are calling it slope point, which makes sense because in order, it's the slope and then it's the point. So I like that. So why, and then it says why you chose to use that form. Why did you guys choose to use slope point form? You know, so why would you choose to use that form? What makes the most sense? What would you tell someone? Yeah, someone says it makes the most sense since we have all of those ingredients. We have everything that's necessary. And yeah, they gave us those things. Very good. So let me just give some people some points here. So exactly, I would say it exactly like you did. Could someone what if they said, no, I really want it in slope intercept form? Could you take this and could you change it to slope intercept form? Absolutely, right? You would multiply out and then you would get it to look like y equals mx plus b. So you would that's what algebra is. You're manipulating an equation to make it look like how you want. Right. So same thing with Play-Doh, right? You have this blob of Play-Doh and I'm like, guys, can you make me I don't know, the thing that I could always make in Play-Doh and in Legos, I know you guys are thinking like, she's amazing, is a staircase. That's the biggest thing that I could probably make for you in Play-Doh or Legos. So can you manipulate this blob of Play-Doh into, I don't know, a little tiny, version of SpongeBob? And you're like, yes, I can. So you would take the Play-Doh and you would push and smush and squeeze or whatever until he looked like SpongeBob, right? So same thing goes with equations. You can manipulate it until it gets to the point where it looks like what you want it to look like. All right. Next couple questions. Linear, exponential, neither. Which one? Linear, exponential, neither. Yeah, it's linear. And we know it's linear because it says x to the first, right? Yeah, linear, exactly. Very good. It is linear. And for those of you who are unsure of why it's linear, they also said write the equation of the what? Oh, line, right? I know. Yeah, tell me. Yeah, as long as I understand what you're talking about. Someone asked, can I use abbreviations in the exam? And I say yes. And someone says, it's because I'm a bad speller. Even when you guys spell things wrong, I still understand what you're talking about. Does that make sense? You are not going to fail this final because you spelled something wrong. Now, if you spell linear like exponential, then that's a completely different problem, right? All right. So this one says the function is continuous, discrete, or neither. How could you tell from this equation? How would you be able to tell if it's continuous, discrete, or neither? Yeah, it's continuous. Very good. Why is it continuous? Why is this one continuous? Yeah. Part of it is because when I graph this, can you all picture when I graph this? Right? It's just a line. It's like boom, right? Yeah, it's a line. So it's continuous. It's continuous. It does not show you specific point that it excluded. Does that make sense? I know. Someone said, but Miss Johnson, I thought linear was spelled Exponential. No, Okay, so the reason why this is continuous is because if I asked you to draw me a line, you guys would draw me something that looked like this, right? Boop. Actually, in this case, it would probably look more like boop, right? It's a negative line, negative sloped line. So it looked like this, right? So notice this is continuous, right? There's no gaps, there's no holes, there's no jumps. Okay, the domain of the function. Now, if this is your function, remind me how do I find domain? How do I find domain? Which way do I look? From what to what? Yeah, look from left to right. Are there any values excluded? Yeah, there's no values excluded. So what is my domain? It's the fancy R, right? All real numbers. Yeah. You could put rational, but I prefer real. Does that make sense? All real numbers. I'm just going to tell you right now, for those of you who are worried about domain questions on the test, it's not going to be a big part of the test. It's only going to be a very small, a little amount. Because for those of you who are like, man, Ms. Johnson, I always forget. Not a big deal. He doesn't play a major role in our final. Okay. Because if you get all this right here, well, actually, if you get this right here and you get these wrong, you're still passing the final. Yeah. Let's go back to this problem. It says, write the equation for Joe's monthly income as a function of n, the number of accounts that Joe solicits. Name the form of the equation that you wrote. And we wrote this, right? So if you picture this, this is a line, right? But then when you think about the actual context of it, what is the domain of this problem? So this is earlier. So it would, so remember that n is the number of counts. Could we have 1.5 in there? Yeah, that's exactly what it is. And everyone's like, no, you can't have a half a number in there. Okay, so I can't have fractions and I can't have decimals. So what kind of numbers are though? Yeah, yes, I was talking to you. So what kind of numbers are there? Yeah, it's natural numbers, or I would even go with whole numbers. The only difference between whole numbers and natural numbers is whole numbers include 0, natural doesn't. Yeah. So if you wrote natural numbers, I'm giving you 90%. Like that's all perfect. Thank you. Okay, so here I would put natural numbers. It's the fancy n. It has 2 sticks. That's all. But I really actually want the whole numbers. Okay, so if you put natural numbers or whole numbers, I'm marking you right. Don't worry about that. And again, domain, not a major player in our final. Are there going to be questions on there? Yes. But is it going to be like 1 through 50? I don't even know if there's 50 questions on the final. Sorry, I didn't mean to freak you out. 1 through 20, domain questions, 21. Graph this line. It's not going to be like that. Okay. So I'm going to move you on to the next question. Yeah, somewhere around 25 questions. That's correct. So write the equation of the geometric sequence with a constant ratio of 5 and a first term of -3. The form of the equation you wrote and why you chose. Okay, so what do I already know? Based on this information, what do I already know? Yeah, it's exponential. How did you know it was exponential? Someone say something. Yeah, they said constant ratio. Whenever they use this word here, they're saying, hey, I'm exponential. Okay, so for sure it's exponential. It says write the equation of a geometric sequence. So here's another clue. Geometric sequence. When I say geometric sequence, what are you thinking? When I say geometric sequence, what else information did they tell you in all of here? Yes, they told you to multiply. No, it's not continuous, actually. It's not continuous. It is discrete. So a little reminder, this is a good reminder. So a sequence is like a pattern that you guys have seen before. So it would look like this. So they said that the first term is -3. So it looks like this, -3, comma. What's my next term? Yeah, the next term is going to be multiply by 5. So that's -15. What's my next term? So here I'm just multiplying by 5, right? So yeah, this one would be what, negative 75, I think. Yeah, thank you. Comma, dot, dot, dot. Is that okay? You guys all fun? Are you all fun with, sorry, I can't think right now. Are you all okay with negative, like all of these numbers, right? Yeah, fine. Yes, are you all having fun? Okay. So with that being said, this is why it's called discrete, not right continuous, because I don't have in-betweeners, right? We don't have any in-betweeners here. So is that okay? Anybody who said it was continuous, does that now make sense? Yeah. Okay. Because it's discrete, it also, no. Someone asked, is this true with most exponentials? No. It's actually true with sequences, but not with exponentials, because exponentials, I can actually do that. And there's an example down here and you'll see it. So, so what would the domain of the function be? Now that we know it's discrete, hint, hint, nudge, nudge, wink, wink. If it's discrete, can I have the domain being all real numbers? If it's discrete, can I have the domain being all real numbers? No, because there's no in-betweeners. Very good. Very good. Very good. You guys are doing fantastic. Right? Yeah, so we can call these natural numbers, we can call these whole numbers, but because we started with first term, I am going to use and actually I'm just going to be honest with you, if you wrote whole numbers here, if you wrote natural numbers, it's both correct. So far so good. So then we would just have to write our equation. What equation would you like to write? So here, just reminding you for exponentials, we could either write the explicit form or we could write recursive. Explicit or recursive. Someone said, I like recursive better. That makes sense. The reason why that person probably did that is because look, if you're given the initial value, all you'd have to do is plug in that 5 right there. So very good. Someone asked him, Ms. Johnson, why doesn't this one get negative numbers? So in reality, if I say that this is my first term, 0th term kind of makes sense, but the negative first term does not make sense. Good question though. Does that make sense? So whenever I'm giving you a list, pretend I gave you a grocery list and I said, I need bananas, I need peanut butter, crunchy, of course. There's a big fight in our household right now, smooth versus crunchy. I know some people won't want to talk to me after this. It's okay. I'm okay. So I give you a list. I say bananas, peanut butter, bread, and flour. Okay. So the first thing on my list is bananas. The second thing on my list is peanut butter. Is there such thing as a negative second thing on my list? No, right? So I think about a sequence as a list of things, right? First, so if I put you guys in they're like, hey, Ms. Johnson, can you give me a list of the students in your class, who are fantastic? I'd be like, yes, I can give it. So I'd put first name, comma, second name, comma, third name, comma, right? I'd put your names here. Yeah. And they're like, hey, who's that negative 4th person on your list? That doesn't make sense, right? Like, say what? Who's the negative 4th person on my list? That doesn't exist. So that's the reason why we wrote natural numbers or whole numbers. Yeah. Oh my gosh, how could I forget? Okay. So last but not least, we need to write an equation. Someone said, Ms. Johnson, I really like recursive. I'm going to write recursive. I'm actually going to write both so you guys can see. So here's my recursive function. It's going to be f of n equals to 5 times f of, oops, Ms. Johnson, she's writing too many parentheses, f of n minus 1, knowing that f of 1 equals to 5, negative 3. Sorry. Okay. Okay, so that's recursive. Here's explicit. Explicit looks like this. My writing is even funkier when I'm sick. That's funny. So it's ab to the x. That is my equation, right? A is going to be my first term times b, which is going to be my ratio. And then to the x depends on if I can get this right. So if I plug in 1, I want it to be -3, but it's -3 times 5. So then I say -1, and that's how I get it. Does that make sense? So -3 times 5, oh yeah, times 5 to the x minus 1. This is not the only equation you could have done. Okay. There's other equations you could have written based on which term you plug in here. Remember, we talked about that. So just like we have kind of like a point slope form for linear equations, it's not called a point slope form for exponentials because there's no slope. Well, you don't understand what the slope actually is in an exponential yet. All right, let's move on. I am going to make you do this one, but I'm going to have you pause really quick and have you start this one on your own. And then we're going to get to this one down here. Okay. It isn't integrated to one. Yes. Yes, exactly. You'll learn this pretty soon. So try number 4 based on this graph. And if you're done, then move on to number 5. And I think that's where we're going to kind of end. The rest of this stuff is stuff that you can try on your own. Except for number 8. I'll go and do number 8 since I talked about it earlier. Okay, so we will get some more stuff done. So can you please try number 4? All right, so you should look at this and instantly know what was the very first thing that you should see. What's the very first thing that you should see off of this picture? Yes, yay, it's linear, check. And someone else said I can also tell that it's continuous. Do you guys also agree that this should also be continuous?
Yes.
Wow, I got a yes out loud. Look at you, you fancy. Okay, so the other thing, let's see, write the equation. So we haven't written the equation, we haven't written the form, and then domain of the function. Which one do you want to do first? Equation, form, domain. Okay, domain. What is the domain? So what is our domain in this case? Yes, all real numbers. Why are they all real numbers, y'all? So I'm going to show you something that is not all real numbers, okay? So something like this would be not all real numbers. So let's say that I had like a line that looked like this. Do you see how if I look on the left side, there's no blue part here. So that's number 1. That's not all real numbers. Another thing is, another example of not all real numbers would be something like this, where there's just random dots or curves. See how when I look from left to right, there's a bunch of like X's that are not being used. Does that make sense? Yeah. So this would also be considered not continuous, right? This is not because I'm jumping, I'm stopping. Does that make sense? Okay. So this is what all real numbers looks like. Let's continue. Which form would you rather use? Looking at this equation, which form would you use? Oh, okay. People said y equals mx plus b, like the slope intercept. Oh, that makes sense because look, I can find my slope and I see my intercept. Now, someone said, no, I really want to use slope point. Would you understand why they would want to use slope point as well? Yeah, right? Because Ms. Johnson, look, I have a point. There's my slope. It's the same. So if you chose slope point, if you chose slope intercept, it makes sense. Now, some of you are a little bit more comfortable with slope intercept, which is why I say, I know, now I'm calling it slope point. Now this is what I want. Some of you are more comfortable with slope intercept. So you're like, every single time I see a line, I'm going after slope intercept. Absolutely do that. Some of you are like, I'm going to try out this slope point thing just so I can get better at it. Absolutely. Okay. But I do want to encourage you to be efficient with whatever you do use. Does that make sense? So someone said my equation is y equals 3/4 x plus 5 minus 5. I'm sorry, I couldn't read it. Someone said, oops, can't read this. Hold on. Let's see if this is correct. So here I get 3/4, so up 3/4. I agree with that. But is our intercept -5? Is our intercept -5? Look very carefully with your young, very specific eyes. Oh, okay, mistype. Sorry, y'all. It's a mistype. It was supposed to be a 3. Very good. Okay, so this is the equation. Now, if someone said, no, Miss Johnson, no worries. Don't even say sorry. I'm glad that you, so again, I like when you guys make mistakes, because when you make mistakes, you're actually like, that's actually stronger learning than if you got it right the very first time, no mistakes, right? So if you were to write the y equals m, which is still 3/4, x minus, and then a point, and you can use any point you want. Let me see. Let me find a good point. I want to use this point right here. So this point right here is 8,3. So I would put 8 here plus 3. And so some of you are like, Ms. Johnson, I really don't believe that these two equations are the same. They actually are, right? They actually are. So even though they look different, their value is the same. All right, I got to finish one last problem that I promised you. Here, someone asked earlier, are exponential functions always discrete? This exponential function is not discrete. This exponential function is not discrete. If I pulled over Desmos, it would look something like this, right? It goes here and then it boom, right? What do you know from the equation that helps you graph the function? So if I asked you to graph this, right, the very first thing that I would graph, just this is a reminder, this is kind of like our review before our test, right? So the very first thing that I would graph is I would plug in 0. And what's 2 to the 0? You guys are like, oh, that's 1. Very good. And then if I plug in 1, what's 2 to the 1? Oh, that's 2. And if I plug in 2, then I get 4. So Miss Johnson, I could also just plug this into Desmos, right? Yeah. But if you plug in something wrong, your brain will tell you if you did it right or wrong by your checks, right? So the actual graph looks like this, right? Sorry, it got a little crookedy there, but this is basically what your graph will kind of look like, right? So yeah, this one is continuous. This is exponential. The domain for this, wait, quick question. What about the domain for this? What do you think? Yeah, very good. All real numbers. Fantastic. Fantastic. Great job learning. So what I would like you to do and the whole point of this lesson is, can you tell the difference between when I tell you some information, can you tell if it's exponential or not? So in the real world or outside of math class, people use this phrase a lot. They say, man, and it grew exponentially. And actually, when they're describing whatever they're describing, it's not actually exponential. So exponential really goes crazy after a certain number. So like if I start plugging in 10 here, 2 to the 10th is 1024, right? So that's big, that's gigantic. That is exponential. But if you're saying like, oh my gosh, this tweet, and viral is kind of like the equivalent of exponential. It went viral and it has like 4 views on it. No, that's not it. Does that make sense? So my hope for you is that you all understand the difference between something that's linear and exponential, whether I give you an equation, if I give you a context, if I give you the graph, it's all there. Okay. So thank you so much for listening.